I'd like to welcome you to the Bristol Community College Environmental Technology Laboratory. In today's activity, what we're going to be dealing with is groundwater. And since groundwater makes up about half of the drinking water in the United States, it's very important that we have a good understanding of the groundwater and the systems that are involved with it. And so today we're going to be using an awesome piece of equipment called a groundwater simulator. And with this device, we're going to be doing several activities that are dealing with understanding of how water moves through the ground. To begin, we're going to go through the setup of the instrument. And notice there are various valves in the back of the device. And what we're going to be doing is make sure the proper ones are open and closed. In order to fill the simulator, we want to make sure that the outlet valve is closed. We also want to make sure that the valve that's leading to the sand, the actual aquifers, is also closed. But we want to open the other valves for the time being so that water can go in there and fill up the unit. So what we're going to do is attach this hose. It's good to do this next to a sink. And we're going to start to fill the unit. And we're going to fill it up to this water level right here. Once the water starts to come up, it's going to start emptying into the aquifer and starting to fill up the simulator. And so we'll wait for that. As that goes up, it'll take a little while for the sand and everything to fill up with water. So now you can see the water is emptying into here. This is porous, so the water is now going into the simulator. And if you can see it, you can see the water rising in the wells. Hey, once you can see that the water level has risen in here, and you can see the wells are pretty full, you want to lower the water level back to the level that's marked on the system. And so to do that, we'll just open up that valve in the back and just drain some of the water out. Okay. Now we want to fill up the pump. And this is basically an aquarium type pump, and this is going to provide the recharge water for our aquifer. So we want to fill up that container. There's 2 chambers in there. Want to make sure they're both full. And we're going to plug in the pump. And now what we have to do is get the water level to rise so that it comes up and fills the pump. So what we're basically having to do is try and get the air out of that line. So if you push that over to the right, and just do a few see, water levels coming up. Now you can see the water start to spill into the aquifer. And then we can actually control the flow two ways by moving this back and forth, and also by moving this device, which opens and closes the space. Right there. If you have it too much, you can see how it'll overflow. So we can reduce the flow. So if it's all the way over to the left, you get the maximum flow. Over to the right, you get the minimum flow. And this is going to control the level of water in the wells, because this is the recharge area. And so there are two parts on the aquifer. This is the area of recharge, and this is the stream. This is the area of discharge. We can control the level in the stream by adjusting this valve. And you just have to play with it to get it to the point where it becomes stable. And then this valve can control the water level in the lake. And that depends on the water level in the wells. Now, one of the things that we can show is we can use dye in here to show the level of the water in the wells. And this simulator actually has three types of aquifers. We have an unconfined aquifer. An unconfined aquifer is an aquifer that has a water table. And so the water table can rise and fall. We'll look at that in a moment. A confined aquifer is one that's confined on the top and the bottom, so that the aquifer area is always full and it's pressurized. And so then we have also another type of confined aquifer. This is a bedrock aquifer. And this is an aquifer that's right in solid rock, like granite or volcanic rock. And so where the water is, rather than in the groundwater here, the water is moving through the sand grains. In this confined aquifer, which is a bedrock aquifer, the water actually moves through cracks in the rock. So there's bigger cracks, bigger spaces that fill the area. What I'm going to do now is to put in a little bit of dye at the top of each well so that we can see the level of the water in the wells. I'm not going to put the water in these for a moment because I'll be talking about these two later. But here you can see where the water level is in these wells. And now you can also see that the water level in the lake has risen. We can adjust that. And if you watch, that can also adjust the level of water in some of the aquifers, in some of the wells. So we'll leave some of the water in there. Okay, one of the first things we're going to do is get an idea of what is the direction of flow in groundwater, which is an important thing when we're looking at an aquifer, and a lot of things that we do, what we're going to plan, how we're going to work with the land that's around an aquifer, is understanding the way that the water flows. And water flows in an aquifer by gravity. So what we will look at, we'll use GIMP. I don't know if people used to go to camp and you used to make a lot of things out of GIMP. This is just your simple piece of GIMP and some tape. And so we're going to first look at the water levels in the unconfined aquifer. And the wells that deal with the water in the unconfined aquifer are wells 3, wells 4, and wells 5. And so I'm going to put a piece of tape to hold the GIMP here right at well 3. So we can see it right at the level. And then we're going to follow the contour of wells 4 and 5. So you can see here's the level of well 4, here's the level of well 5. So if we put that right there. So we can see, following the lines, that the well is higher here and lower here. That means that by gravity, the water is going to flow from a higher to a lower area, so the water is flowing in this direction. An interesting thing also is if we look at this line, we also see that the water in the lake is right about at the center of that. And the reason for that is many lakes are what's known as spring-fed lakes. And so the water is actually coming from the aquifer into the lake. So this is actually the water table. So this line is showing the water table in that aquifer. And it passes right through the center of this lake. Right here, because this lake is being fed by the water from the aquifer. Now another measure of the slope of this, the slope of the line that looks at how the water table is going, is known as the hydraulic gradient. And so the hydraulic gradient, just like a gradient when you look at rise over run on a graph, that's the same here. We're going to look at the rise, or the fall of the water level from this height, from this location to this location, and then the distance between the wells. So we would just put this across and measure the distance from this well, center of this well, to the center of this well, and get that measurement. And then from here we would also get a measurement of the distance from that line up to the top of the well. And then we would do the calculation where we have y2 minus y1 over x2 minus x1 to give us the slope of the line. And that's the hydraulic gradient. So that's one of the things that we can do with this well, which is a hydrological parameter that's of concern. Now, another thing that we'll want to do is measure how fast is the water traveling through the aquifer. So what we can do is measure a couple of points. Right here, say, from the start of this